This is an Acrotech ball head, and you'll notice it's installed upside down. Normally the base is here, and these are flipped. And the reason it's like this is because you can use the panning base as a panning head. All you have to do is level it out. You should be able to rotate it the whole way around, and it'll stay level. So I'm using the Acrotech upside down as a base. Does that make sense? If not, don't worry about it. I'll explain something else in a minute. So now that I've adjusted the bubble level, sorry it's a little blown out there, I'm going to take this plate, which is a right angle plate, and attach it to the ball head. This also has a bubble level on it. Hard to read because it's blown out. There you go. And it should also be accurate. In fact, as long as I pan around, the bubble level should remain level, which is what you want. You don't want your panoramas to be sagging. And again, this is partly because I'm using Acrotech ball head upside down. You could use a leveling base instead. All right, next step. The next step is to attach the vertical rail, as you can see here, to the right angle and clamp it down. The height adjustment is not that important at this point. But you'll notice what's on this rail. There is a head here. It's a rotating head. I don't really like this. It's too flimsy, but that's how you tighten it up. I've already marked out the locations where this should sit, including my information should it get lost. So this is what it looks like without the camera attached. You can do horizontal this way, vertical this way. So it's a multi-row panoramic rig. The only other things to adjust are the plate locations so that the lens is centered over, and the location along this rail so that you have the correct distance. Does that make sense? I'll show you those in a minute. First couple things. This is a Nikon D600, and you'll notice I have a short strap on it. It's a little overkill, but not a long strap. I also have my connection here so that I can remotely control the camera, which is why my L bracket is attached off to the side, not flush against it. Otherwise, that plug right there would stick out and it wouldn't work. Okay, L bracket's a great thing. This has an index mark. Only that mark I've actually marked with a silver marker, and there's a mark over here as well. Okay, those markers should define the center of the lens, the center of the field of view. This now attaches here. You'll notice that I can clamp it down, and the distance and so forth will be worked out in a moment. Another interesting point, you'll notice I use some gaffer's tape over the eyepiece. That's because this camera and several other Nikons leak light unless you can close this off. So I often have it like this. I take it off if I want to do something. Now, you'll notice I've attached here, this is my index mark. That's so that the center of the lens, the center of the sensor, is in this rotational axis. Likewise, what I need to do is to make sure this rotational axis is directly over the location where it rotates. Right now you can see it's a little bit offset. You just simply slide this rail to make that adjustment. Those two things you need to do before you do anything else. So the next step in the adjustment is to make sure that the vertical center is directly aligned over the rotational point. Now this particular Acrotech ball head has an index mark, and there's marks here on the rail. So once I know which camera I'm attached, which kind of bracket, I can actually figure this out and mark it. In fact, I showed you earlier that I have markings here pre-marked to know how far to set the lens back, but we'll get to that in a minute. You want this centered over. It'll be something kind of like this. Right, center of rotation. Accuracy is important for stitch panoramas. So it looks like the 105 marker is about what I want to get this lens perfectly centered. All right, now we go to the next. Let me give you another tip. If you look very carefully through the viewfinder of my camera, which you're doing right now, you'll see that right there is the center of my sensor. It's marked as the viewfinder of the camera. It also happens that this tripod has a screw in it. It's hard to see here, but if the screw is exactly in the right is in the center of this field of view, then my left to right orientation is correct. You want that to be correct. I also wanted to show you a little tip. Remember, I have this short strap. I actually keep it looped over the bracket. If the camera were to fall, this strap should catch it. This strap is thin, it's not big enough to catch the wind, which is what you don't want. This rig is pretty stable right now. It's not locked down. We can lock it down. And it's pretty stable. And this tripod is not extended very much at the moment. Now, the final thing that you need to do is to figure out where to move this bar relative to the vertical column. And you determine that by figuring out the nodal point, which is usually right about here in the lens. So this part has to move back to here, which means we're going to slide this rail that way. There's an adjustment right down here. Got to be careful about this or your camera can fall off. And it's hard to do one-handed, so I will just adjust it. All right, this is now adjusted. You'll notice there's an index mark again on this clamp at 0. You also notice down here I've measured 62 millimeters, so that's why I want the 0 on the 62 millimeters. And then I know that my lens is actually in the correct position. The nodal point is here, so that when it rotates around the nodal point. That's important to get a good stitched panorama. Now, how did I come up with that? That's the next video. A little more complicated, but it's pretty simple. Here's how we've set up our camera so that we can check to make sure we find the nodal point. You notice the camera is set up, it's leveled out, it's centered over the base so that the axis of rotation is correct. And we have in front of us something sticking up here. I just picked something silver. It's actually on a light stand, which is kind of unimportant. But behind is something kind of busy, but that I can measure against. So the next image I'm going to show you is looking through the camera. All right, I'm ready to figure out where the nodal point is on the camera. I'm going to point out right here is that screw, that silver, that stands up. Watch the background as I move the lens from left to right. Notice how the background moves. In this location, it's right behind that brown post. But when I move this way, it goes a long ways away. So we are not on the nodal point. I'm going to change the location of the camera on the slide. And by the way, what I just did was pretty close to what you would get if you just rotated around the base of the lens. So I'm going to move this forward, this backward, so that the lens nodal point, which is about here, is about where the rotation is. Does that make sense? And then we'll look at it again. Here's the second pass. Again, here is the screw that's silver and shiny. It's not that easy to tell. And there's a marking on my camera. So when I have the marking inside my viewfinder lined up with that screw, I'm now going to rotate the camera to the left. And notice what happens is the screw moves slightly from left to right. You see, in this position there is a dark board behind this that you can see. In this position it ends up going behind. So I'm not quite in the right spot. I will just have to move it again. Is there a way to tell which way to move? Yes. Do I know it? No. So you can fiddle with this a little bit. Here we are again. You noticed I've aligned the screw with the dark board in the background, and I've moved the camera quite a farther back than when I've done it before. So I'm not sure why this is going to work, but let's see. Come on. Okay. So when the camera is at the left edge, this line and the screw, everything aligns. I'm going to pan to the right. Notice how the brown board behind stays at the same position relative to the foreground object. We now have reached the nodal point. Notice there's extremely little movement. Everything's in the same relationship. That means there's no parallax here. This is exactly what you want to do. Once you know what it is, mark it down and don't forget it.